Our today's lesson is on linear regression. You can use a graphing calculator to fit a line to a set of paired numerical data that have a strong positive or negative correlation. The calculator uses a method called linear regression, which involves minimizing the sum or squares of the residuals. And the name of the game is you're going to get the residuals like we did in the previous lessons, and you want to square them and add them up. And whatever has the lowest sum is the one that has the best line of fit. Okay, we're going to do the same as the previous lesson, except we're going to square the residual at the end. For example, if t is 0, then we get 29.2. And if you take the difference between the two, which is the same as the actual value, you get 0, and the square of 0 is 0. So if I plug in 10, I should get 31.52. If I take the difference, I get negative 0.22. And if I square that, I get 0.0484. If I plug in 20 for t, I should get 33.84. And if I take the difference of that, I get 0.16. And if I square that, I get 0.0256. And if I plug in 30 for t, I should get 36.16. And the difference would be 0.34. And I square the result, I get 0.1156. All right, and if I plug in 40 for t, I get 38.48. You take the difference, you should get negative 0.28. And if you square that, you should get 0.0784. But before we do that, let's compare it to another function where the slope is 0.25t and the y-intercept is 28.8. And we're going to go through the same process. So, same thing. Let's say when I plug in 0, I get 28.8. I subtract 28.8 from 29.2, I get 0.4. And if I square that, I get 0.16. So I'm going to go through the same process. I plug in 10 for t, I should get 31.3. And of course the difference of this is going to be 0. And you square 0, you get 0. If I plug in 20 for t, you should get 33.8. And if I take the difference, I'm going to get 0.2. I square the result, I get 0.04. If I plug in 30 for t, I get 36.3. I take the difference, I get 0.2. And again, I square that, I get 0.04. If I plug in 40 for t, I get 38.8. I take the difference between the two, I get negative 0.6. If I square the result, I get 0.36. All right, so when you do all that, all right, now we're going to add up the residuals, the square of the residuals, and see which one has the lowest sum. So let's look at this first function. And the squares of the residuals was 0, 0.0484, 0.0256, and so on. And you're going to add these up, and you should get 0.268. Let's compare that to the other function. And the residual on this is 0.16, 0, 0.04. And if you add these up, you get 0.6. But this is the lesser of the two, so that's why this model is the better fit. This concludes our lesson for today.